This is a second lesson in our series of computational thinking. Today we're going to be thinking about thinking ahead, looking at inputs, outputs and preconditions. Here you can see the key learning from the PLC for this lesson. And our keywords have been added, including preconditions, cache, inputs and outputs. Now remember our abstracted model. A computational program can be thought of as having an input and an output. This should be fairly simple for you. An input, remember, is information which is relevant to the project, and an output is information which could be passed back from the project. Think about this as a subroutine now. A subroutine often has parameters passed to them and out of them. It's important that we actually abstract a model, as we looked at this last lesson. But there are often two major challenges when producing a problem to a computational problem. The algorithm must be correct and it must work for all possible inputs, and this is key. If it doesn't work for certain inputs, then we have not got a successful algorithm. And algorithms must be efficient. Often they have to process huge amounts of data, so finding an efficient algorithm becomes important. This is not just for memory, it also saves us time as a programmer. For your project, you're going to have to be creating algorithms before you start the programming. And to do that, you need to be planning out your inputs and outputs. And you're going to have to do something along these lines. It's really important when we have a series of subprograms, which could be functions or procedures, that we think of the inputs and outputs that are going to be used in these subprograms. Here's an example. I've got a program called findMax. We pass it a list of integers. I've called this listInt. It starts from I1 to an indeterminate number. We don't know how many items are going to be in this list. My outputs is just going to be a simple integer, maximum integer, the biggest number. That could be returning a value or it could be printing a value. Now there is a massive advantage to us documenting these inputs and outputs, so there's no ambiguity. We know exactly what that function and procedure should be able to do. And remember, when we're documenting code and programs, think back to our software development unit that we've recently done. It's important when we create design and design specifications before we make the project that it can be programmed by anybody. This is because there may be a team of people programming our worksheets, our workshops and our programs rather. Please look for your worksheet, which is on Google Classroom, and complete task 1. So we thought about inputs and outputs. However, I now want us to think about something different called a precondition. But before we move on to that, pause the video and have a look at this code. What's wrong with it? Hopefully you figured out that this program would actually crash. The reason for this is because if there's no value in our list and it's empty, then the program will not be able to run. So we need to ensure that we can handle this. Here are two different methods that we could use. We could insert a line at the beginning of the function to check for an empty list. For example, if len of the list equals 0, we could return something. This is pretty similar to a try and except. Method 2 is making sure we do not call the function with an empty list. Method 2 actually makes it the responsibility of the person calling the function to check that it's not an empty list. And this is quite a good way of doing it. This leads us on to preconditions. To stop a problem like that, we want to specify our preconditions when we're planning. So for example, here's our find maximum of a list. We want to make sure our length of our list is greater than 0. Can you think of any other preconditions you might include? Hopefully you've come up with things such as they'd only be allowed to be integers. Try task 2 in the worksheet. On the worksheet, you'll see now it's asking you for inputs, outputs and preconditions. Now in your coursework you are going to have to be doing preconditions as well. So the advantages of preconditions are, first of all, it makes the program components reusable. It actually, with clearly documenting a precondition, tells the programmer what they need to do. What do they have to be careful of? And this makes the function reusable. It cuts out any unnecessary checks. With a clear statement of preconditions, the programmer knows what to check before calling the subprogram and what's unnecessary. If you're calling a method such as sleep and you were to put a value, so time.sleep and in brackets a, well, it wouldn't know what to do, it would crash. So our preconditions for that would be it's an integer. But most of us know that sending a letter to a sleep wouldn't work. We know those preconditions. But by telling the programmer that, we prepare them for using our functions and procedures, particularly if we're working together. This makes our programs a lot easier to debug and maintain. If there's a problem, we can go through them quite quickly. We have talked about documentation, remember, in the last unit. Well-defined and documented functions and procedures can be used in many different programs. We can recall them. Remember that lesson we did looking at how to reuse functions and procedures from different programs. We can almost make a library and import what we need. And remember, when we're in the compilation process, there are linkers and loaders. Our linkers pull the libraries from our programs into our code, into our compiled code. In a large project, this is saving us time in writing testing functions, which should really be written by the programmer rather than us who are writing methods at this point where other people might use those. Now, this is particularly important if you were to join a company. Quite often they have what's called programming standards. If programming modules are to be reused when you're in a company, you will want to be working the same way, so that if you're working in a team, you will have the same structures. And quite often you have programming standards for global and local variables. You might not be allowed to use global variables at a certain company. You might have to document something in a certain way. Here are some typical standards for reusing modules. Inputs and output preconditions should be documented. Variable identifiers should be in a certain standard. So for example, you might have camel case or you might be using snake case. All variables must be local to the module, and this is quite a frequent one in programming companies. Documents should be a certain way. You might have a certain look, a certain feel, there might be certain information you might need to include. You might have explanations of certain sections of code using comments. And you might even have length criteria. So modules or functions and procedures should only be a certain length. Please complete the next task, task number 2, looking at two lists and what happens when we add these two lists up. It's important that we specify outputs, inputs and preconditions when we're designing a project. We need to anticipate what the user will do next. And this is also going to have an impact on the menu design, so think of our graphical user interfaces. And now I want you to think about caching. We've heard this term before in the CPU. Remember, a cache in the CPU is a small amount of data and instructions that are held close to the CU and inside the CPU. So they are frequently used instructions. We can also see caching in web pages and HTML. When you're using a website, the cache stores a copy of the HTML. So imagine that you've opened a new website. If you were to close your computer and open that website again, it might be the fact that that website is already stored in your web cache. In school we have a web server. So if people are accessing the same websites frequently, we're going to keep calling the same copy. Imagine it like this. A student doing an assignment requires a lengthy research paper in a large library. Every time she comes to the library to work on an assignment, she asks the librarian to fetch the paper from the reference section, which is 2 floors down. Instead of having to go to the basement every time to get the book, then you could keep it on a shelf behind them, and problem solved. There are clear advantages of this. First of all, web caching using proxy servers, so like a web server, means faster access to cached resources, saves on costly bandwidth, and reduces the load on a web server. However, there are some drawbacks of caching. That are things like slower performance. If it's not found in the cache, it's spent that time searching for it, and it then has to go and find that website from the web server somewhere on the internet. You could be given a stale copy of a resource. when up-to-date copy is potentially needed. This is because the website would already be cached. It automatically updates every few minutes anyway, but you could be looking at an old version.